Okay, this is lesson 5.3. It starts with the review questions on it. So the questions go like this. We're asked to find, we're told that RU is an altitude and SV is a median. So immediately go to your drawing and put under marks. RV is 6a plus 3. And RT, which is the whole thing, is 10a plus 4. So let's put 6a plus a plus 3 right there. So that means that this one has to be 6a plus 3. So the piece plus the piece equals the whole. So it takes 2 of the 6a plus 3 to equal the whole, which is 10a plus 14. Okay, and so then you would solve that one, but I'm not going to solve that in this video. You can do that on your own. The next one says find y if the measure of angle RUS is 7y plus 27. RUS is this angle right there, which is also perpendicular. So the equation you would set up for this one would be 7y plus 27 equals 90. And then the center of gravity of a triangle is the centroid that goes with the median. So that's just a little bit different term. Okay, so this lesson is talking about inequalities. Inequalities you can solve just like equations, and that's all this really says. But this one is a little bit different, that if A is less than B and B and A are equal to each other, this is the comparison of it, so you could do this either way. You could have A less than B or A greater than B. Alright, inequalities in one triangle. The measure of the exterior angle, this is the exterior angle. This is greater than the measure of the corresponding remote interior angles. Remember, those are the remote interior angles because they're all the way across on the other side. Another characteristic that you have to remember with these is that the exterior angle happens where one of the sides of the triangle extends way out, and it's on the outside of that triangle. When we're applying this property, they're going to ask you to figure out which angles are smaller. We're doing this with exterior angle theorem. So when you get questions like this is with the exterior angle theorem. So using the properties of that, they want you to list all the angles whose measure is less than the measure of angle 4. So angle 4 is right here. It's on the outside, so that's an exterior angle. So if you look at the triangles that are remote to this, this little triangle right here, so you've got 2 and 5 are remote to it. So angle 2 and angle 4, or 5, excuse me, have to be less than the measure of angle 4. Well, angle 4 is also an exterior angle to this big triangle with 7 and 8 as its remotes. So 7 and 8 also have to be smaller than that. Oops, angle 8. Okay, all the angles whose measure is greater than angle 8. You're going to look at that and think, okay, which of these angles are remote exterior angles for angle 8? If angle 8 is a remote interior angle, so is angle 6 for this triangle on the left. So angle 9 has to be bigger. And then angle 5 is also an exterior angle, so it's remote with 7. So angle 7, angle 5 is the remote exterior angle that goes with that. And then also, if we look at the big triangle here, you've got this 4 on the outside, and this angle at the top, if I just do the triangle with angle 7 here, angle 3 here, and then this angle at the top is angle 8 plus angle 2. Angle 8 plus angle 2 still has to be smaller than the measure of angle 4 by the exterior angle theorem of inequality. So angle 8, or angle 4, is also greater than the measure of angle 8. And I should clarify that this is the exterior angle inequality theorem. So on these, even though angle 3 does look like it's smaller than angle 4, we're doing this all just by the exterior angle inequality theorem. So it has to be proved by that theorem, nothing else. Okay, inequalities in one triangle. It turns out that the smallest angle is across from the smallest side in a triangle. So, for example, angle 7 is here. Angle 9 is here. This is smaller, a smaller side. So because of that, the angle across from it, angle X, is also smaller. It works the other way too. If this angle is the smallest, this 45-degree angle, then JL is the smallest side. So we'll test this out. So we look at this, and if I list the angle, it says to list the sides, but I'm going to start with the angles. Angle B is the smallest side. Okay, the next angle is angle C. I'm going to call that the medium side. And then you've got angle A. That's the big side. This is the biggest angle. Angles. So we've got the small, medium, and biggest angles. Okay, so that means that across from angle B is side AC. Across from angle C is side AB, and across from angle A is side BC. Now, if you're observing this, the smallest angle is the letter B, right? And the other two vertices, A and C, are the smallest sides. So you can kind of tell because it's the side is made of the letters that were not used for the angle. Okay, so if we're going to do the same thing for this one, listing the angles from least to greatest, the least small angle on this one, we don't know yet because we still have to figure out from the perimeter what this is right here. The perimeter is the sum of the sides, x plus 8 plus 11 equals 28. So first we have to solve for x on this one. Okay, take away 19, and you end up with x is equal to 7 on 8 on that one. Let's try a 9. So x is equal to 9 on that one. Okay, so x is equal to 9. So now that I know that this is 9, I know that angle E is the smallest. I know that angle L is the next biggest. And I know that angle M is the largest. Okay, Ebony's making a handkerchief, and it turns out that she's folded it in half, and the directions say to tie the two smaller angles of the triangle under her hair. So the two smaller angles are going to be the ones across from the 16. That would be angle Y and angle Z. This one lists the sides of a triangle in order from least to greatest. So they give us the angles. We know the sum of the angles equals 180. So from here we can go and say, okay, the measure of angle A plus the measure of angle B plus the measure of angle C all equals 180 degrees. So we know that the measure of angle A is 4x plus 10 plus 6x minus 3 plus 2x plus 5 equals 180 degrees. When we go through and solve this, you end up with x equals 14. So we're going to take that 14 and plug it in here, and when we do that, we get angle A is 66, angle B is 81, Angle C is 33. And if you recall, I told you whatever, so this is the smallest, right? And this is the medium, and then this is the biggest. So the smallest angle, we're going from least to greatest again. Angle C is across from side AB. Remember, you're using the other letters. The medium side is angle A, which is across from BC. And then you have angle A, angle B is the biggest. So that's across from angles A, or side AC. Okay, so that would be the sides in order from least to greatest. Then we get to these lovely things. So with these, it's a little bit tricky, but you just look at the two triangles separately and then put them together. So on this triangle, on the left one, 60 is the smallest, that's angle W, and it's across from DK. And then, oh, I'm sorry, I went the wrong way. Okay, angle 50 is the smallest angle, and that's across from WK. So WK is across from angle D. That's the smallest. The next one then is angle W. So the next side is DK in this triangle. And I'm going to change these commas to inequalities. And then we have DW, which is the biggest side on the triangle because it's across from angle K. Okay, so that's for this left triangle. For the right triangle, side DN is the smallest. And then you have side NK, which is the medium, and then you have angle DK, or side DK, which is the biggest. So we want the longest in the figure. If you notice, everything on the right side is smaller than DK. Well, also WK is smaller than DK. The only one that's not smaller than DK is this DW that's right here. It's the biggest one. So DW is the largest. And that is the end. Your assignment is in the lab. For this assignment, I put it in the lesson instructions. So go there and find it. But that's what this is. Hope you have a good night. Bye.